guys. All right, today we are doing lesson 12.3, which is going to focus on multiplying and dividing monomials and polynomials. In other words, we are going to multiply a monomial by either 2 or 3 or 4 or even more terms, and we're going to divide multiple terms by a monomial. Now, before we jump into today's lesson, we need to do a review about exponent rules. So we have used these several times throughout the year, so hopefully they sound familiar to you. But remember, when we multiply two powers that have the same base, in other words, if you look at number 1, the base is x. And so because x to the 5th power times x to the 2nd power both has the base of x, we can add the exponents. Or remember, the other way we could think about this is this would be like x times x times x times x times x. That would be x to the 5th power times x, that would be x squared. And so you see, because you are multiplying x 7 times, we could also say that this is x to the 5 plus 2, which is x to the 7th power. When we multiply powers with the same base, we can add the exponents. As we go to number 2, remember that if there is no exponent, we can put a 1 there. So this would be y to the 1 plus 4, which is y to the 5th power. When we divide powers that have the same base, we subtract the exponents. Because remember, on number 3, for example, on the top you would have w times w 9 times, and on the bottom you'd have w times w times w 7 times. And so w divided by w is 1. So essentially you'd be able to cross off 7 pairs of w's and only be left with 2 on the top. Or the other way of thinking about that is it is w to the 9 minus 7, which is w squared. And the last one in this review section, number 4, x times x, well, this would be like x to the 1st power times x to the 1st power, so this is x to the 1 plus 1, which is x squared. This is a good time to just remember that x plus x is 2x, and x times x is x squared. We've talked about that relationship several times, but it's going to be really important to us today especially. All right, now that we've reviewed that skill, we can jump into multiplying a monomial, and we're going to start by multiplying it by a binomial, in other words, something with 2 terms. Now, again, these are all skills that we have used before. Essentially, we're going to be using the distributive property here as we multiply one thing by multiple things, and we're going to use those exponent rules that we just reviewed. So none of the skills today are new, but we are just simply dealing with expressions that are more complicated than we have looked at before. And there's going to just be more things to keep track of because we're going to have more exponents to deal with. But again, the skill is something we have already done. All right, so let's take A. I am first on A going to make this plus -3. And so they've already set up the work for you. And so I'm going to make that plus and that a -3. I just think it's easier to keep change so that you don't lose your negative sign. You don't have to do that, but you can. So in this problem, I am going to be distributing the 4x. In other words, I'm going to multiply 4x by 6x and 4x by -3. Well, 4x times 6x. Okay. Remember, you have to ask, what is your base? In this problem, the base is x. So you can multiply the coefficients and add the exponents, which in this case would be a 1 and a 1. So this would be 24x squared plus -12x, or you could also have minus 12x. As always, I want to make sure that my answer is in standard form, which means I need to make sure that nothing else can be combined and that my highest exponent comes first and it goes from greatest to least, which in this problem, all of that is true, so I am done. Let's take B now. Notice B, we see the binomial first and then the monomial. Well, we're still going to distribute the monomial. We're still going to distribute that 1 term to the 2 terms. So we have 2c times -7c squared and 3 times -7c squared. All right, well, in the first pair of terms, c is the base, so I can multiply the coefficients. 2 times -7 is -14, and then I have c to the first power times c squared, so that would be c to the third power when I add those exponents. Then on the next one, I have 3 times -7, that's -21, and there's nothing to multiply the c by, so I keep that as just c squared there. And again, I want to make sure it's in standard form, which this is, so I am done. So if you remember, we've gotten really good at you guys have gotten really good at the distributive property, so a lot of times we haven't been showing this step when we are distributing, but I would encourage you, especially as you're getting started with this lesson, to show that step since we're dealing with much more complicated terms. All right, let's do a little bit more practice. So number 1, we are distributing that 3x. So I have 3x times 5x plus 3x times 6. This one's just a little bit easier because nothing's negative. So in the first pair of terms, x is the base, so I can multiply the coefficients and add the exponents. I get 15x squared plus 18x. Again, those can't be combined because they are not like terms. They don't have identical variable parts. So that's my final answer. Why don't you pause the video right now, try 2 and 3, and when you're ready to check your answers, press play again. All right, go ahead and check your answers with mine. Notice on number 3, when you're doing a squared times a squared, that's a to the 4th power. And then in that next set of terms, you have a squared times -7a. So the -7 has nothing to be multiplied by, but a squared times a would be a to the 3rd power. And always make sure your answers are in standard form. All right, let's go on to the next page. Now we are going to multiply a monomial, so still one term, but this time by a trinomial, so 3 terms. Now, here's the deal, guys. We're doing the exact same things, the exact same set of skills. There's just one more thing that we have to multiply it by. So, as we look at a, y squared is the monomial, so that's what's getting distributed. That's what we are multiplying by the other terms in the parentheses. Just like always, I am going to keep change. I'm going to make that plus -10y. Because I don't want to lose that negative sign. And I'm multiplying each term by y squared. All right, so in the first set of terms, I have 8y to the 4th power, because y squared times y squared is y to the 4th power. Then plus -10y to the 3rd power, because I have y squared times y. And then plus y squared, or you could put 1y squared if you wanted. All right, again, make sure it's in standard form, which this is, so I am good to go because there's nothing else to combine there. Look at the next one. Ooh, this one has 2 variables, which is totally fine. You can absolutely have 2 variables. So my monomial is this mn, and that's going to get distributed to everything in the parentheses. I'm going to make this plus -2n, and so I have 3m times mn, 6m times mn, and -2n times mn. All right, so remember each of these would have an exponent of 1. So this first pair I have 3, and then I would get m squared n, because there's 2 m's, but still just 1 n. Then I have 6m squared n squared. Let me pause right here and let you know you need to be careful that you don't write this, I'm going to come over here to the side, as 6mn squared, saying, well, that whole thing is squared. Well, this would indicate that only the n is squared. So you could technically write this like that and put the mn in parentheses to show that that whole thing is raised to the 2nd power, but I think it's easier just to put m squared and n squared to show that both of those are squared, or there's 2 of each of them, okay? And then I have plus -2mn squared. All right, now notice that throughout my problem, I always want to keep my variables in alphabetical order, so I kept m coming first and then n throughout this problem. All right, now let's talk about standard form when we have multiple variables, okay? So when we talk about the highest degree coming first, that means if there's more than one variable, we have to add the exponents within that same term to get what the degree is of that entire term. In other words, this term would have a degree of 3 because 2 plus 1 is 3. This would have a degree of 4 because 2 plus 2 is 4. And this would have a degree of 3 because, again, 1 plus 2 is 3. So when we write this in standard form, the 6m squared n squared has to come first because that term has the highest degree. Then you say, okay, well, the next two both have a degree of 3, so how do I know what comes first? Well, the rule is that if they have the same degree, then you look at the variable that comes first in alphabetical order. So in this case, that would be m. So I would put 3m squared n coming next because the m has a higher degree and it comes first in alphabetical order. And then plus negative 2m n squared. And that would be standard form for this problem. And again, nothing else can be combined there because while we have lots of m and n's, we don't have any identical variable parts there. All right, let's do a little bit more practice. So number 1, I have 3x times 4x squared plus 3x times, I'm going to make that plus negative, so times negative 1x plus 3x times 2. All right, so in that first pair, I end up with 12x to the third power plus negative 3x squared plus 6x, and that would be standard form because there's nothing that can be combined, and my exponents go from greatest to least. Be careful with those exponents and with the negative signs. Let's do number 2. I have negative 8y times 2y squared plus negative 8y times 3y plus negative 8y times negative 5, because again, I'm going to make that plus negative 5. All right, so when I multiply my first two terms, I can multiply the coefficients first, so that's negative 16y to the third power plus negative 24y squared plus positive 40y, because I have a negative times a negative there. And that would be my final answer. So why don't you take just a moment, pause the video, and try 3 and 4. All right, go ahead and check your answers with mine. Let's take just a minute to look at 4, because again, this is another one that has two variables, a C and a D. So you'll notice I distributed 2CD to everything. Now, when we talk about standard form here, so this term would have a degree of 4 because you have the C to the first power and D to the third, so 1 plus 3 is 4. This one also has a degree of 4. This one has a degree of 2. So we know for sure the one that has a degree of 2 comes last, but both of those have a degree of 4, so how do we know what comes first? Well, again, when they have the same degree, remember we go alphabetical order. In this case, C comes before D, and so we use the term that has the higher exponent on C. And so that would be negative 14c squared d squared, and then plus 2cd to the third power. So you look at the degree of the whole term, and then move towards looking towards the degree of the letter that comes first in alphabetical order. All right, now let's move on and look at a little bit of dividing. So we are going to divide a polynomial, meaning something that has multiple terms. So it could have 2 terms, 3 terms, 4 terms, but we're going to look at dividing something with multiple terms by a monomial, in other words, by one term. So as you look at this first example that they give you, we have a trinomial divided by a monomial. And we know when we are dividing something, in this case, basically what we're saying is that each term here has to get divided by that 3x to the third power, because this entire polynomial is divided by that. So the first thing I'm going to do is rewrite this as basically the 3 separate terms that it is, and show that each of those is divided by 3x to the third power. All right, now Again, we need to then ask, what is the base? So as we look at this first pair of terms here, I'm looking right there, I see that x is the base. So first of all, I know that I can do negative 12 divided by 3. Those are the coefficients, and so that's negative 4. And then I would have x to the 6 minus 3 because I subtract the exponents, and so this would be negative 4x to the third power. Then moving on to the next term. Again, x is still the coefficient, and so x is still the base, so I can divide the coefficients, which is 15 divided by 3, that's 5, and then I have x to the 5 minus 3, so this would be the term 5x squared. And finally, I have x is still my base, so I can do negative 3 divided by 3 because those are my coefficients. That gives me negative 1. Then I have x to the 3 minus 3, and so basically that cancels itself out because that would be x to the 0 term, and remember, anything to the 0 is just 1, or the other way that you can think about this is, x to the third power over x to the third power would cancel each other out. All of those x's cancel, so this would finally just be plus negative 1 or minus 1 at the end. So I did this in less steps than they gave you written out here on the side because I kind of combined a couple of their steps all into one. But again, you always want to make sure that you look at the coefficients and the powers when you're dealing with each term. Let's practice a couple more of these. So number 1, I'm going to first write this as each term divided by negative 3. I'm also going to do a keep change and make that plus negative 15x just so that I don't lose that negative sign there. So this time I'm dividing by just a number. There's no variable with that, and that's fine. All right, so the first term here would be negative 3x squared, and then positive 5x, and then negative 2 as I take that term by term. Make sure there's nothing else that can be combined and that you're in standard form, that your exponents go from greatest to least, which I am, so that's my final answer. Let's look at number 2 now. I have 35x to the third power, and I'm going to divide that by 5x. Each of these terms in the trinomial on top are going to get divided by 5x. Notice I did a keep change there so that this was plus negative 25x at the end so that I don't lose that negative sign. All right, so on the first set of terms, x is my base, 35 and 5 are my coefficients, so I can divide those, which gives me 7x, and this would be to the second power since it's 3 minus 1. Then on the next pair of terms, 5 divided by 5 is 1, and x squared over x, so this would be 2 minus 1 is just 1. So you can write it as 1x to the first power, or this term could simply be written as x. You could get rid of both of those 1s. And then I have plus, and this would be negative 5. The x divided by x cancels, so this here is my final answer. All right, why don't you take just a minute and try 3 and 4. These are the last 2 that we're going to do today. All right, take a look at 3 and 4. 3 looks pretty similar to ones that we've already done, but I want to take just a second to look at number 4. Because as you look at number 4, you notice that in the first pair of terms, 16 divides by 4 evenly, that goes in 4 times. But then in that middle set of terms, we have negative 10 divided by 4. Well, negative 10 does not divide by 4 evenly. That does not give me a whole number. And so it's okay if that happens. You can leave it as a fraction. You just always want to make sure that your fraction is in simplest form. And so because 2 goes into 10 and 4, I want to simplify that to negative 5 over 2. So this would be negative 5 over 2 x squared. That x squared can either go in the numerator, so this could be negative 5x squared over 2, or it can go over to the side like I have shown you as I wrote it. But just again, make sure that if it doesn't go in evenly, that you still reduce the fraction if it can be. And then at the end there, 12 divided by 4 is 3, and x squared would cancel since one's on top and one's on the bottom. And again, always make sure your answer is in standard form. All right, that's all for today. Have a great day.